All right, so 6.6, we're doing basically 6.3 through 6.5, and we're putting it together in each example. And then 6.7, 6.8 are basically applications. So like what word problems can support everything we've been doing. So 6.6, logarithmic and exponential equations. This is just a reminder that you switch between both of them. And also this is a reminder. Oh, my bad, I forgot to switch it over. That's just a reminder. And another reminder is when you have log with the same base equal each other, you can get rid of the bases and solve it that way. But before you do this part right here, before you drop the bases, you need to make sure that you move over r. So you need to make that number in front be an exponent always. So, example 1. The first thing we're going to do is move that 2 over. So we have log base 5, x squared equals log base 5 of 9. So after you move over the r, you just want to see if you can do this. You want to combine logarithms if possible. So meaning, you see how example 2, we have log plus a log? We can combine those. So in this case, we don't have any logs adding or subtracting to each other, so we can go ahead and cancel these out. We can cancel these out because they have the same log and base. So we are left with x squared equals 9. We take the square root to get x equals positive negative 3. Perfect. Yep. So yes and no with that. You need to find the domain. What makes this x 0? What makes that 0? 0. So x must be greater than 0. In this case, it worked. That works exactly how you said it. So which one of these is greater than 0, positive or negative 3? Positive. Not always. You'll see for the next example.
So x is always going to be greater than 0?
In this problem, yes.
In this problem,
That's the domain. Yep. This is the worst example to show you domain and how to pick an answer. Example 2 will clear that up. Bless you.
Can you start by finding domain?
Yes, you can start finding it, yeah. We will actually, for the rest of examples, do it first. Yeah. So there's no checking your answers. You just need to make sure that those answers fit in the domain. All right, any questions for me? Doing okay so far? All righty. Example 2. So let's find the domain first, since that tells us what we can and cannot have for answers. So we should like to see it first. What makes that 0? Negative 6. What makes this 0? Negative 2. You only care about the highest number because If it's greater than negative 2, it's greater than negative 6. You don't want any of these to be 0. So in order for none of the underlying ones to be 0, every single one, the answer needs to be greater than negative 2. So you only care about the biggest number in your domain. Are there any r's to move over? Nope, there's no number in front of the logarithm. So let's move on to the next thing we're going to ask ourselves. Can we combine anything? Yes. We can combine log base 5. We have x plus 6, x plus 2 equals 1. Nope, we can't do that.
Not in this case.
No, not in this case. I was about to get to that. So you see in example 1 and example 2. In example 1, we have logs on both sides. That's going with the property that we have logs on both sides. On this problem,
This is plus, not equals to.
yep, and there's no log on that side. So you have to approach it differently. You always combine it no matter what you're working with. You want to combine things to make it as small as you can. So from here, we can go ahead and switch this to an exponent, because we can say we have base 5 equals 1 to the power of 1 equals, and then we can FOIL this to x squared plus 8x plus 12. Now, can't we solve this now? Yeah, we can easily solve this by subtracting 5 to both sides, because 5 to the power of 1 is just 5. So we get x squared plus 8x plus 7 equals 0. And remember, anytime you have x squared, it must equal 0. That's how you're going to solve for it. From here, we factor to get x plus 7, x plus 1 equals 0. And hopefully by now, we can go ahead and say that this is x equals negative 7 and x equals negative 1. You just take the opposite.
Sorry, but where did that log went to? Did it
We
disappear?
changed to exponent.
Oh.
Yeah, so from here to here, we went to exponent. Yeah, if you don't have logs on both sides, you're going to most likely change it to an exponent. Now, which one of these answers fits into our domain? Just negative 1.
The highest one.
It's not always the highest one, but for the domain, yes, we want to look at the highest one. But sometimes you can have both answers work, sometimes you only have one, or sometimes none of them can work. It's multiple choice, so you won't even have to worry about that. Yep. But yeah, it would be wrong. Yeah. Any questions for me? How'd you find the homework over besides the graphing? Because I know how you guys felt about that. It's because you didn't change the base.
Terrible.
Yep. Wow.
It took me like 10.
Yeah?
Yeah.
Wow.
Like all day Sunday. 'Cause I watched the Georgia game Saturday. I wasn't doing it on Saturday.
Ma'am.
So I left it off for Sunday.
Yeah, I can see that you like the Georgia Bulldogs. Yep. Just a little bit.
Just a little bit.
Okay, so my
You got
question is, why did you choose negative 1 instead of negative 7?
Because the domain, we're looking at the bigger number in the domain. So is negative 7 greater than negative 2? No. Is negative 1 greater than negative 2?
Yes.
Yes, that's why we picked that one. Well, I really appreciate that you guys actually do your homework. I know it takes a while, but I really do appreciate it, and it will pay off for this test on Tuesday. Want to move on? Okay. I'm trying to show you one of everything because, as you see on the homework, there's many types of problems you can encounter. So I'm trying to show you one of everything. All right, example 3. Is there any r to move over? Nope. Can we combine? Yep. We have ln x equals ln x plus 6 divided by x minus 4. Because it's a minus, yep. Now, do these have the same logarithms? Yes. Because they do, we can go ahead and drop them and say x equals x plus 6 over x minus 4. Yes? Let me number things. Number 1? Okay. So where did I get this x from? I just rewrote it from the top. Okay. So from here, we have an x in the denominator. If we have an x in the denominator, we need to get rid of it. We get rid of it by doing what? Yeah, multiplying by it. So we multiply everything by x minus 4. So when we do that, it cancels out on this side, and all we're left with is x squared minus 4x equals x plus 6. So we just distribute that x to the x minus 4. Now, since it's x squared, what should all of this equal to? 0. Yep. So we subtract x and subtract 6. So we have x squared minus 5x minus 6 equals 0. What's our favorite F word? Factor, right? So we got a factor. We get x minus 6, x plus 1 equals 0. So we get x is 6 and x is negative 1. How do we determine what answer is right or not? It's the domain. You see how it really doesn't matter if you do it first or last? I'm just trying to show you that it doesn't matter when you find it, and hopefully it kind of solidifies that the domain means everything with your answer. So what makes this 0? Negative 6. What makes that 0? 4.
We don't do that first one, ln x, on the left side of the
Yep.
equal? Oh.
I just started on the right. Don't know why. And what makes that x 0? 0. Right. So which number do we care about? 4. Which one of these falls under that? 6. Thank you. Absolutely perfect. Yeah.
So when it's x, is it always going to be greater than 0? I mean,
Yeah. Yeah. When it's just x, yeah. Yes.
So why do you care if it falls under by 4 instead of negative 6?
So if we chose negative 1, right? Is negative 1 greater than negative 6? It is. Yeah, right, because negative, not positive. So, but if I put that right here, it works. But if I put it right here, does that work? That's why we care about the biggest number. Really good question. Are we still doing okay? All right. Well, because the rest, you were learning to do this. Now that you have that foundation, you can do it. Let's just say that. All right, so you are going to write something. Don't write it yet. I want to explain some stuff. And that's why I left a space up here for you. All right, do you notice any differences? There's 2 differences between example 4 and example 5. What are the differences between example 4 and example 5? Both sides have an exponent. And then what's happening to those exponents? Yeah, you're adding and subtracting to it. Those are the 2 differences between example 4 and example 5. So you have to approach these 2 different ways. And here are the 2 different ways. One way is very long, one way is very short. Oh no, they're completely different. Yeah. So please write both of these. I'll explain them. So the one on the right, that's change of base formula. You do that if you just have one x and there's no adding or subtracting with the x. So just like example 5. If you have something that looks like example 4, where there's x's on both sides, and or when there's an x that has a positive or negative, so like it's adding or subtracting to the x, you have to do these 6 steps. And you do this to solve exponential functions, or exponential equations with different bases. So now that you can tell the difference between examples, you'll know when to use the 6 steps or when to use change of base formula. So for example 4, are we going to do change of base formula? No. One big reason, there's x's on both sides. Since there's x's on both sides, you automatically know you have to do the 6 steps. So let's do that. The first step is to move over r. My bad, sorry. Is to put a log in front of it. I changed that. So our first step is to do log or ln. I'm so sorry, let's do ln for this one. Next one is log. So we have ln 5 x plus 3 equals ln 3 2x minus 5. So now that we put our log or ln in front of it, or in front of it, why can we do that? Why is that fair? Why can't we just say, well, I'm just going to willy-nilly put ln in front of this and call it a day? Then it's fair, yeah. I can multiply 8 to both of these sides. To do it, will it help me solve for x? No, but I can do it. So it's just like an old school scale. You want both sides to be balanced. That's why if you do something to one side, you have to do it to the other. So from there, that's when we move our r to front. So we have x plus 3 ln 5 equals 2x minus 5 ln 3. Now that we moved over our r, we distribute. So we're going to distribute our ln to our binomial. And this is the easiest distribution you can ever do because you're not actually going to do anything. You're just going to put it next to each other. So you'll have x ln 5 plus 3 ln 5 equals 2x ln 3 minus 5 ln 3. So you see how we didn't combine anything at all? We didn't multiply anything at all. We just put it next to it. So now that we distributed, we can go ahead and keep simplifying for x by putting all the logs with x's on one side and all the logs without x's on another. So we're going to subtract 2x ln 3 to both sides. And then we're going to subtract 3 ln 5 to both sides. So what we're left with is x ln 5 minus 2x ln 3 equals negative 5 ln 3 minus 3 ln 5. Are you able to follow along with the steps you wrote? You see what I'm doing every single time? That's for this example, that's all I want you to try and do, is just you see, okay, I'm grouping the x's on one side, putting everything else on the other. That's step 4. Now step 5 is to factor out the x. You see how they both have x in common? That means we can take it out. So we have x ln 5 minus 2 ln 3 equals negative 5 ln 3, bless you, minus 3 ln 5. The last step, we divide. Because we're doing x times ln 5 minus 2 ln 3, we just divide it out. So we divide by ln 5 minus 2 ln 3. And when we do that, we have x equals negative 5 ln 3 minus 3 ln, ln 5 all over ln 5 minus 2 ln 3. That is your exact solution, your approximate. I will show you how to put this into the calculator for the last example of the day. We get 17.56. That's it, he says sarcastically.
And you should remember all the steps.
Yep. But what's great is that every single step, if you're working with this type of problem, is the same every single time. So you see that when we have 2 more examples that we do these steps, you are legitimately doing the same thing every single time. That's why I love math so much. It's so consistent. I crave consistency. So it's okay if you did not know what we did, like understand it, but what I do want you to do for this example, were you able to follow the steps in what I was doing? Were you able to say, okay, I can see that we're adding ln to both sides, that's step 1, and so on?
How do we know when to use ln or log?
You can use either one. Yeah, and you'll see for the next example, I'll use log. Yep. They're all interchangeable because log with no base is base 10, which is the same thing as a natural log. Okay. Okay. Any questions? No? Cool. Thanks for most of you shaking your head. I love the cat ears. Panda ears? What are the ears? Because they're cute? Yeah, I gotcha. Something my wife would have, yeah. They're all sparkly and glittery. I want it, yep. Yeah. Alrighty, example 5. So for example 5, are we going to do the 6 steps? Nope. There's just x on one side, and there's nothing adding or subtracting to the x. So we just do the change of base formula. The change of base formula, super easy. You can either use log or ln, because they're both natural logs. So we put what it equals on top, and the base on the bottom. My bad, I didn't mean to write a 5. That's your exact solution, and your approximate would be 2.32. Done. This is just like the last example from Thursday, except instead of using logarithms to do change of base, we have exponents that we're doing change of base.
So the one with the x will be the base?
Yes.
At the bottom?
Yep. So for B, what's the first thing we should do?
Multiply 8 into
Not multiply, divide. Good thinking though. We need to do something with that 8. We need to either get rid of it or multiply it, and we're always going to get rid of it. So we have 3 to the power of x equals 5/8. That's always fun to say, 5/8. Bixby thought I was talking to it. I was not. Yesterday in class, I was doing log base b of x, and when you say that fast, it sounds like Bixby. So my phone kept trying to do stuff. All right, so since we isolated the exponent, which is the base with the exponent, we can go ahead and do change of base. So we could do x equals ln 5/8 over ln 3, and the approximate version would be negative 0.428. Do not worry on the test. First of all, it's multiple choice, so you can see what kind of answers I want, and I also will explicitly ask. This is the only multiple choice test for the normal semester. The final does not include the normal semester.
So chapter 5 is going to be written.
It will be written, yep.
We only have like 1 in the final?
Yeah, this 5 and the final. Yeah. It's November tomorrow. It's crazy, right? I'm so ready for this semester to be over with. Man, and it's not you guys. Like, I really enjoy my classes this semester. It's just the way this semester started. It really, messed up with the flow of it all. And I've never had to experience that as a professor, so I'm just like, I don't understand how other professors do it when they have to take, 2 or 3 weeks off because stuff happens, At least we don't have to make it up, because, I know if you're in high school, you have to make it up in the summertime, and I'm so sorry. I would be so mad.
They wanted to cut my sister's Thanksgiving and Christmas break.
Really? No, you can't do that.
Many people have already planned.
Exactly.
They did that for Dr. Phillips. The first 3 days of Thanksgiving, right? You have to be in school.
Oh yeah, because you get the whole week off during Thanksgiving, huh? Yeah. Lucky. All right. Example 6. Example 6. Do we have to do the 6 steps, or can we use change of base? Nope, 6 steps. Not change of base, because there's x's on both sides, and then what's happening to those x's? Yep, there's addition and subtraction. So this time I'm going to use log. You could also use ln. So I'm going to change these to be log 5. X minus 2 equals log 3, 3x plus 2.
I just have a question.
Yeah.
How would you write it if you were going to use ln the same way? But
Just put ln.
That's it?
Yep.
Okay.
Yep. Yeah, most people just put ln because it's 1 letter less you have to write. Yeah. It does not matter, though, which one you have to use. So what are we going to do with each exponent? Yep, move it to the front. It is chilly in here. So we get on the front x minus 2 log 5 equals 3x plus 2 log 3. What do you do with the logs?
Plug it into x and negative 2.
Yep, distribute. That's fine. You knew what to do. That's all that matters. So we get x log 5 minus 2 log 5 equals 3x log 3 plus 2 log 3. What should you do with the x's? Yep, group them, move them to one side. So we subtract 3x log 3 to both sides. And then we add 2 log 5 to both sides. So when we do, we are left with x log 5 minus 3x log 3 equals 2 log 3 plus 2 log 5. So you notice, same exact thing, just different numbers. What do we do with the x? Factor. Then we'll divide. Yep. So we have log 5 minus 3 log 3 equals 2 log 3 plus 2 log 5. Now we divide to get x by itself. So when we divide by a log 5 minus 3 log 3. So we get x equals 2 log 3 plus 2 log 5 all over log 5 minus 3 log 3. That is our exact solution, our approximate. And again, I'll show you on the next example how to do that with your calculator. It's negative 3.2116. So you're going to see this one more time, but seeing this again, a little less scary. I get it. I really do. I'm not going to say this is easy because it is not. All right, any questions? I have to like sit on my hands for a bit. My hands are freezing. Oh, all right. I'm one of those people in the wintertime, my hands and feet get super, super, super cold. Like my ring will fall off. And so I always mess with my wife. She hates cold feet. So I'll put them in her face. She's the one who said yes to me, so that's on her. She knew what she was getting herself into. We lived together for a year before we got married, or no, 2 years before we got married, so that's all her. I moved to Florida and never went back.
You haven't?
Nope, I know. I never went back to where I was. I was only supposed to visit.
Florida?
Yep.
Me
And I stayed.
That's how I stayed here.
5 years later, I'm still here. Don't know why. No, I love this place. It's so nice. I love Orlando.
It's pretty.
Yeah. All right, so example 7. So you will have something like this on the test. The population of the world in 2009 was 6.78 billion people and was growing at a rate of 1.14% per year. Assuming that this growth rate continues, the model P of t equals 6.78 times 1.0114 to the power of t minus 2009. Right, that is a mouthful. Represents the population P in billions of people in year t. So A and B are the same exact thing. We're only going to do A. I picked A because it's the harder one, because it's a decimal. According to this model, when will the population of the world be 8.7 billion people? So they're asking when will. When will, does that represent T or P? T. So we're trying to find T. What else do they give us? Yep. The people, the population. So P equals 8.7. Now we don't need to put 8.7 billion because the P already stands for billions of people. Let's plug this into our formula. We have 8.7 equals 6.78 times 1.0114 to the power of t minus 2009. Can we do change of base formula? Why not? We're subtracting. You see here how we're subtracting to the x, in this case it's a t. So because of that, we cannot use change of base formula. We need to do the 6 steps. Yep, you can't use change of base.
We can't just divide both sides by 6.78.
Well, we will, but that only works if you have to the power of just x or just t. Yeah. So yes, the first thing we will do is get rid of 6.78. Why? Because we can. We want to move everything we can away from the t as much as possible, so we will divide by 6.78. So when we do, we're left with 1.28 equals 1.0114 to the power of t minus 2009. What now?
Log.
Log. Yep, we can do log or ln. What do you want to do?
ln is
ln. ln. Okay. Let's do ln. So we're going to add ln to both sides. We have ln 1.28 equals ln 1.0114 to the power of t minus 2009. What do we need to do with that exponent? Move it to the front. Now, could you just do that in one step, add ln and move it to the front? Yes. Question?
If we do ln before dividing everything to 6.78,
No, do not put the ln before.
do we need to divide for
You need to divide first, then put the ln. Yeah, great question. So yeah, let's put it in front. We have ln 1.28 equals t minus 2009 times ln 1.0114. Now what? Yep, we're going to distribute. So we distribute our ln to the t and to 2009. So we have ln 1.28 equals t ln 1.0114 minus 2009 ln 1.0114. What would you do next? Say again? Well, we don't need to move the t. The 2009. Yeah, we want to isolate the t, so we move the logarithm with 2009 in it. So we have ln 1.28 plus 2009 ln 1.0114 equals t times ln 1.0114. Now we can divide. Because that t is multiplying to the logarithm, we can divide it out. So the part I highlighted, that's the exact answer. But does that exact answer tell you what year that is? No, right? So you need to use your calculator. So once you guys are ready, I'm going to pull the calculator up and show you how to plug this into your calculator. Yes, round up, yeah. All right, can I switch to the calculator view? No, go ahead, keep writing. Yeah.
Our answer, is that going to be the actual year, or is that how many years we live?
No, that will be the actual year.
Okay.
Yeah. 2031?
Huh?
2031?
2021.
31. Yeah, make sure you put everything in right. That's like too close for comfort. All right, I'm going to show the calculator. So right here, that's the numerator, right? Just make sure you wrap each logarithm in parentheses. So parentheses ln 1.28, close the parentheses, plus parentheses 2009 ln 1.0114, close the parentheses, press enter, then divide that by ln 1.0114. And we get the year is approximately 2031.
Like a little sheet saying how we can use the calculator with steps?
Nope. Yeah, you can't. If you're getting weird answers on your calculator, because you know how answers should be, right? Like, it makes sense by 2031 we would have 8.7 billion people. So, like, if you got a decimal, they'd be like, that seems weird, right? You can come to me and ask for calculator help. I will help you. And even then, if you ask me a question on the test, I'm either going to help you or not help you. So it doesn't hurt to come and ask. I may or may not help you. You never know.
Suck if I got that one question, I got 2021 instead on the test.
I would give it to you. I would give it to you.
Weird.
That is weird. Were you able to get 2031 after?
Yeah, after 2 tries.
Yeah, that is very interesting.